More trigonometric equations. So again, it needs some preparation. I'm integrating sine x divided by cos square. You could think maybe it could be log because you have a derivative of the numerator, but you are missing the square. So the derivative of this one would be 2 cos sine. So it's definitely not the denominator derivative. So I would say you have to learn a trick that is quite helpful when you have a trigonometric function and then divide by cos square or sine square, which is separating your cos square into, so I have sine x divided by cos x times 1 over cos x dx. Yeah, the first part is sine divided by cos, which is tan. The second part, the reciprocal of the cos, remember, is sec s. And we know how to integrate this because this is sec s, sec x, and it's in your formula booklet. Yeah. E. I have integral of cos square 3x. Remember one trick we used when we have sine square? We're going to use the same. So the double angle formulae for the cos, so cos 2x can be written with cos square, with sine square, or with both. So in case of cos square is 2 cos square x minus 1. So what we are going to do is to write cos square x as cos 2x plus 1 divided by 2, right? I have cos of 3x, so this is going to be double of this angle. So if I have here 3x, it's going to be 6x. So I'm going to write my integral, and I'm going to take the 2 out. So I have 4 to integral of cos 6x plus 1 dx. And now I can integrate. So I go here and is 2 cos 6x. The integral of cos 6x is sine 6x. But when I derivate sine 6x, I have the 6, so I have to divide by 6 to not have it, and then plus x plus c. You can multiply if you prefer the bracket, so it's 1/3 sine 6x plus 2x plus c. Yeah. And then f is 1 plus sine x square. So f is 1 plus sine x square. We cannot integrate it like it is, so what we can do always is to expand the bracket and see if that helps, because we will have more terms. So we will have 1 square plus 2 sine x plus sine square, and just expanding the brackets, dx. And we know how to integrate easily these two, and this one we can integrate it as with the double angle, the cosine double angle. So we have, I'm going to prepare first. So sine square, just using the cos double angle, remember, is 1 minus cos 2x. We've done that before, divide by 2. So I'm going to write my integral as 1 plus 2 sine x plus 1/2 minus 1/2 cos 2x, just substituting the sine square for all that. We can put together this 1/2 and this 1, so I can write 3/2. 3/2, yeah, and then I can integrate. So when I integrate this, I have integral of sine is cos, but negative, and I have a 2 at the front, so minus 2 cos. Then integral of 3/2 is 3/2 x, and integral of cos 2x is going to be with the minus at the front, and this half is going to be sine 2x. But when I derivate sine 2x, I have a 2, so I need to divide by it, so I don't have it, so this is going to be 4. Yeah? Because when I derivate sine 2x, I have 2. 2 divided by 4 is 1/2. That is what I should have. And then plus c. And that's it, yeah? So more techniques to cope with these trigonometric functions that are not straight forward.